Hello, welcome to another amazing math video. Today we're going to be covering 3.6 slope-intercept form, and we're going to start at this point in the page. Slope-intercept form is one form of graphing a linear equation that we are going to be covering. We're going to cover another one called point-slope form, but that will be another video for another day. So, slope-intercept form. It's a type of linear equation that we use, and it goes like this. Y equals mx plus b. Where m represents your slope and b is your y-intercept. What's nice about slope-intercept form is if you have an equation where it has been solved for y and it's set up like this, you can look at the equation and immediately know what the slope of your line is and what the y-intercept of your line is. You're good to go. So let's take a look at this first example. Y equals 2/3 x plus 1. I look at the number that's being multiplied by x. The number being multiplied by x, this is my slope. So already I know that my slope is 2/3 and my y-intercept, which we're using the letter b to represent, is positive 1. So my slope is 2/3, my y-intercept is 1. It's going to cross my y-axis right there. From there, I'm going to go up 2 and to the right 3. Now I want you to get in the habit of extending your graph all the way across. Up 2 over 3. I can also go down 2 and back 3, down 2 and back 3. At this point, what I'm going to do is get a straight edge and graph my line. And that is graphing in slope-intercept form. Pretty awesome, right? No t-tables. You don't have to calculate the intercepts. You really don't have to do anything except look at the equation and identify the parts. Okay. Again, we started with the y-intercept, and let's label this. This is my y-intercept, and the coordinates are 0, 1. So I started there, and from there I went, let's see, I'm going to use blue. I went up 2 spaces and to the right 3 spaces. Pretty nifty. Okay, let's go ahead and do the next one. If I look at this equation, it's y equals negative x over 3 plus 2. There is a little invisible 1 right there. And what I would like you to do, if you have an equation like this, I want you to take this equation and rewrite it so that we have this y equals mx plus b. The number that I need to put in front of x, my coefficient for x, is going to be negative 1/3. X plus 2. So I took this equation and I transformed it into something that looks a little more like the y equals mx plus b that we talked about. Now I can identify that my slope is negative 1/3, which means my line will be going down, and my y-intercept is 2. We always start at the y-intercept, and from there I'm going to go down 1, right 3. A real common mistake that students make is they will see the negative and they'll say, oh, I need to go down 1 and backwards 3 because it's negative. But if you do that, what kind of line do you get? Positive slope or negative slope? You get a positive slope. Going down, that's hitting the negative direction. Going backwards, that's hitting the negative direction. And if you go negative over a negative, that is actually positive. So be careful with that. Negative 1/3, you're going to go down 1 and to the right 3, and just know that your line should be decreasing because the slope is negative. So you're going to have something that looks like this. Okay, my y-intercept is where we began. The coordinates of the y-intercept are 0, 2. From here we went down 1 and to the right 3. Again, I'd like you to extend this all the way across the graph. Down 1, right 3, up 1, left 3, up 1, left 3. Grab your straight edge. I'm using my awesome name badge here. And extend it all the way across. Add your arrows, and ba-bam, there's your graph. Not too bad, is it? Let's take a look at the next one. Y equals 3x. Now this doesn't have all of the parts, does it? My format is supposed to be y equals mx plus b. But this doesn't have that. This does not have the plus b part. That's kind of freaking me out. Well, if there's nothing here, then what am I adding? This is 3x plus what? Well, it's 3x plus a whole lot of nothing, right? Now that I've set it up like this, I can identify that my slope is 3, which I could also write as 3 over 1. And my y-intercept, that b value, is 0. So we start at 0 on the y-axis. And from here, my slope is 3, or 3 over 1. I'm going to go up 3 and to the right 1. And we're going to extend this all the way across, up 3 again, right 1. I can go down 3 and left 1. I grab my straight edge. And draw my line. Let's take a look at the next example. I want you to graph this equation, but there's a problem. This is not in the correct form, is it? So what we're going to have to do here, if you look at the directions, it says convert into slope-intercept form and then graph. Well, slope-intercept form, remember, that's y equals mx plus b. So what I really need to do is I really need to solve the equation for y. So let's look at our equation. Draw my line. I am trying to isolate this y value, which means I have to get rid of all of the other stuff. I got to get rid of the 3x. I got to get rid of that too. And I'm just going to move all of that junk to the other side. So I start by subtracting 3x from both sides. Those cancel. That leaves me with a positive 2y equals, make sure when you're doing this that you're putting your x first. Don't write this as 8 minus 3x. Write this as negative 3x plus 8. The reason why is because we're trying to land on that y equals mx plus b. So you want to put x first. My y is not totally isolated yet. I need to divide both sides by 2. So I divide everything by 2. and I get y equals, these cancel, y equals negative 3 over 2x plus 4. Now that's a heck of a lot better, isn't it? That's my equation in slope-intercept form. And I can very easily identify my slope as negative 3/2 and my y-intercept as positive 4. So with this information, I'm going to graph my line. My y-intercept is positive 4. My slope tells me that from here, let me write this down. My y-intercept is 0, 4. So those are the coordinates of my y-intercept. From here, I'm going to go down 3 and to the right 2. I want to extend this across my whole graph. Down 3, right 2. I grab my straight edge and draw the line. The reason why I want you to extend it all the way across is so that you end up with a straighter line. Not too shabby, huh? Go ahead and flip your paper over, please. It says, write the equation of a line in slope-intercept form given the slope and a point on the line. Zero, negative 4. I'm going to plot that. 0, negative 4 is right here. That is my y-intercept, isn't it? So if I tell you that a line passes through 0 something, this is going to be the y-intercept. And what this tells me is that m is negative 1/2, b is 4. So when I write my equation, it's going to be y equals negative 1/2 x, be sure to include the x, plus 4. And then if I want to graph it to check, I can, well, not to check, but, just because we're graphing. I'm going to go down 1. It's negative, so I'm going to go down 1 over 2. I can go down 1 over 2 again. I can do it again. I can go up 1 and backwards 2, up 1 and back 2. Grab my straight edge. And here's my line. Second one. The slope is 3, and it passes through the point 2, 4. Now, is this a y-intercept, the point 2, 4? No, it's not, right? 2, 4 is going to be right here. That is definitely not my y-intercept, which is a bummer because it was so easy to write the equation when it was. So this one is not a y-intercept. We're going to have to do a slightly different technique. I want you to know, and I know you already know this, but the 2 is the x value, the 4 is the y value. That's going to help us here. And I know that my slope is 3. What I don't know is my y-intercept. I have to figure out what my y-intercept is. I want to find my y-intercept, which we're calling our b value. So here's the format of the equation, y equals mx plus b. I'm going to plug in everything I know. I definitely know that my slope is 3. I don't know what the y-intercept is, but I do know that when x is 2, y is 4. Again, I'm going to say that one more time. When x is 2, y is 4. So I'm going to plug in 2 for x and 4 for y. Now I look at this equation, and the only thing missing is that b value. The great news is that I can solve for b. And when I do, I get 4 equals 6 plus b. I minus 6 from both sides. And I find that b equals negative 2. Now that I know that, I have all of the information I need. I now know my slope as well as my y-intercept. So when I write my equation is going to be y equals 3x minus 2. And we can graph this. My line should go through this point. So let's check and see if it does. Negative 2 is my y-intercept. My slope tells me to go up 3 over 1. Up 1, 2, 3. I want to do it for the full length of the graph, so I'm going to go up 3 over 1 again, and it does go through this point. I grab my straight edge, draw my line. Remember here, if your slope is 3, if it's an integer, you can write that as 3 over 1 when you're actually graphing. That is sometimes helpful. Let's talk about parallel lines. Think for a second about lines that are parallel. I'm sure you've heard this phrase before. Example of parallel lines might be, I don't know, railroad tracks are often thought of as parallel. Parallel lines are two lines that never touch, and they have the same slope. Okay, so they never intersect, they're never going to touch, they have the same slope. What they look like is that's kind of a lumpy picture of parallel lines, but I think we get the idea. Here's an example of two lines that are parallel. If I have y equals 2/3 x plus 1, the only thing I have to look at to find a parallel line is the slope. That's the only thing I need to focus on. That's the only thing that has to be the same. So a parallel equation might be y equals 2/3 x, or y equals 2/3 x minus 5, or y equals 2/3 x plus 4, or y equals 2/3 x plus or minus anything, as long as the 2/3 and the 2/3 are consistent. As long as my slopes are the same, my lines will be parallel. Perpendicular lines. Perpendicular lines are two lines that form a 90-degree angle. A 90-degree angle would be the corner of your paper. This is 90 degrees. The corners of a square, the way the floor meets the wall, that angle is 90 degrees. Which we call perpendicular. And the slopes are opposite reciprocals of each other. Let me just get that a little bit wider. Forms a 90-degree angle, slopes are opposite reciprocals. And perpendicular lines are going to look like this, where this forms a 90-degree angle, like the corner of a paper, the edge of a table, something like that. So here is an example. Suppose I have y equals 2/3 x plus 1. a perpendicular line to this needs to have the opposite reciprocal. Now, when I say opposite, what I'm referring to are the signs. One is positive, one is negative. When I say reciprocal, what I mean is a flipped fraction. A over B and B over A. These are reciprocals. Opposite reciprocals is where I combine that. So that might be 4 over 7 and negative 7 over 4. Or negative 5 and positive 1/5. These are examples of opposite reciprocals. They have different signs, and they are reciprocals of each other. So back to our problem. The opposite reciprocal of 2/3, well, I know I need to turn this fraction upside down, right? I'm going to take the reciprocal of 2/3, which is 3/2, but I also need to change the sign. So y equals negative 3/2 x, and then we can say whatever we want for this last piece. We could say plus 3, minus 4, plus 1,000. Again, the only thing that matters is the slope. The slopes need to be opposite reciprocals of each other. So this takes us to our next example. Determine whether each pair of equations represents a parallel lines, perpendicular lines, or neither. I look at A. I'm looking at the slope to make this decision. My slopes are 3/4 and 3/4. I recognize that we have the same slope, which means that the lines must be parallel. I'm going to let you do B, and I'm going to let you do C. But I do want to talk about C before I leave you on your own here. Notice that these are not in slope-intercept form. So I can't just highlight something and say, oh, look at this part. This is how you're going to make your decision. I can't do that. What I have to do here is I have to convert this equation into slope-intercept form, so that way I can look at the slope and very clearly see that this is the slope and the other one has the same slope, so they're parallel. Or this is the slope and the other one has the opposite reciprocal slope, so they are perpendicular. Or that they don't have that relationship at all, and it would be neither. So I'll convert the first one, but you're going to have to convert the second one. I have x minus 2y equals 5. I'm solving this for y, so I'm going to minus x from both sides. Those cancel. Negative 2y equals negative x plus 5. I divide everything by negative 2. Those cancel. I have y equals a negative divided by a negative is positive. Remember, there is an invisible 1 here. So this is going to be positive 1/2 x minus 5/2. Don't let that 5/2 freak you out. It doesn't matter. This is the thing we're focusing on. That slope right there. So you can deal with the second equation, convert this into slope-intercept form, and then compare the slopes of the two lines to make your final determination. We are almost done. How exciting is this? Okay. Last example says, write an equation in slope-intercept form of the line whose graph is. We have two conditions, right? We want it to be parallel to the graph of that equation. And if it's parallel, this piece right here tells me that my slope if it's parallel to this equation, y equals 5x minus 7, my slope is going to be 5. Okay. Let's look at this part. It passes through the point 0, 11. If it's 0, 11 graphically, that's going to be right there on the y-axis. So this is actually my y-intercept. So what you've really been given, you've been given the information that you need to find the appropriate slope. You've been given the y-intercept. My slope is 5. My y-intercept is 11. My equation, y equals 5x plus 11. I'm going to let you do B. This time, you're going to have a little bit more work than I did. We want it to be perpendicular to the graph of that linear equation. Look at this part. Look at this part. You're going to have to do some work here. You're going to have to convert this to slope-intercept form. So this is going to be x plus y equals 3. Convert that to slope-intercept form. Choose the appropriate slope and look at your y-intercept and you're good to go. So just to recap, what you need to do, actually what I would like you to do, just a couple problems on your own. We're doing B and C. Okay. Do B, do C, finish C, and then do this last example down here. Please have this ready by the next time we meet, and have a wonderful extended weekend. Thank you.